Surface tension describes the inward pull or force of a liquid. You can see here that water will bead up on a waxy surface. Water is not attracted to this nonpolar waxy surface, nor is it attracted to the air. But it's not repelled by this surface nor the air, but actually just more attracted to itself. It can maximize the amount of hydrogen bonding, a stabilizing force, by decreasing the surface area in contact with everything else. And so, yes, this inward pull or force comes from the hydrogen bonding present in water. Other substances also have surface tension, although oftentimes much less surface tension because they have lower intermolecular attractions. So surface tension not only is useful in informing us how we should wax our cars to prevent our cars from rusting, but it's also informative about why certain things can walk on water and others, like us, can't. Here we have a picture of a water strider in two different cases, one in which it's walking on top of the water and one in which it starts to sink. You can see that when it's walking on top of the water is still able to hydrogen bond, but if it breaks the surface of the water, this high surface tension substance, then it will break what would have been hydrogen bonds between the water molecules. And that would be destabilizing. Now, it's light enough that the effect of gravity is insignificant compared to the stabilization of having hydrogen bonding. So it can walk on water, but we are large enough to break those intermolecular attractions by the force of gravity. We also can talk about viscosity here. This is also related to the amount of attraction between particles. Viscosity is the resistance of fluid to flow, which is strongly correlated with stickiness. The more attracted particles are to each other, the more resistant they are to flow. So you could think of things like molasses. That is kind of can be a glob which moves slowly. It pours slowly. Similarly, increasingly concentrated sugar water solutions are increasingly viscous as well. Sugar has hydrogen bonding between the water molecules. It has OH groups on it, as does glycerol. This book is mentioned in our textbook. This compound is mentioned in our textbook as being particularly high in viscosity because it can hydrogen bond at 3 locations to 3 different glycerol molecules. And so it can become entangled with those, not only because of the hydrogen bonds here, but because it can often form a kind of branched structure which is difficult to pull apart. Thanks for watching, guys.